Here at Sur Mer, we have made a few controllers for foiler boats, like the TF35, which is a sailing foiler. It's a class of boat that race with catamaran foilers, and we have designed a flight controller for those catamarans. But we've also worked on more recent projects, like a project with BMW, which has been made by Tide. It's a boat which is a motorboat. We have designed a completely new software for this flight controller. And now we are working on bigger projects like flying ferries. So for flying ferries, we have worked a lot on the safety of our system. So this system has, for instance, a lot of sensors on board. So the goal of those sensors is to know exactly the position and the movement of the boat, but also of the water. So we have a lot of height sensors that are placed at many locations on the boat. And we have developed algorithms that are able to fuse all those measurements with motion measurements from inertial systems. And these algorithms can bring us a lot of robustness against failures or against noise or spray from the water. For some boats, like flying ferries, we have to develop a system that's very robust, because we have a lot of passengers on board, and those boats really rely on a flight controller. Our flight controller is made to be very robust to any failure. For instance, we are able to have two different controllers on board, and each other is looking after the other, and if one fails, the other take over. In our system, we have a lot of sensors, way more than we really need, and this redundancy we have is very useful in order to be robust to failures. We have developed algorithms that are able to fuse all these measurements, and if any sensor fails, the system will feel nothing actually. These flying boats will turn by banking, by inclining, and not a flat way like regular motorboats. So this is why we have been inspired by the airplane's way to turn. Inclining also brings a lot more efficiency while turning, whereas turning flat is not very efficient for these boats. So the way we control the boats for taking off or landing is as smooth as we can. When the boat takes some speed, when it has enough speed, it will take off, but really smoothly. So the big challenge with motorboats is to be able to foil in very big waves. To do this, we have used a technique we can find in the aerospace or in the aeronautic industry, which will take the most out of each actuator. We have developed a flight controller which is very generic. So we are proud to be able to use this same flight controller for a lot of different boats, be them with sails or with a motor. The only changes we have to make on the flight controller when we pass from a boat to another, it's changing the interfaces with the hardware which is already on board, and to make a little tuning in order to have a dynamic which is adequate with the boat you want to fly. Our flight controller is generic, so we can use it on a small boat, on a small flying boat, or on a big boat, on a sailboat, on a motorboat. We've made it in order to be able to be on any boat. The only thing we have to change is to adapt the system to the hardware. So we have to make some change in the interface with the actuators, the sensors, so on. And we also have to tune some parameters in order to have the dynamic of the flight, which is adequate with the boat we have. So for a little boat, we want a very high dynamic and very reactive. And for ferry boats, big boats, we want a more slow dynamic and something which is safer. We had the chance to work on a simulator in this project, which is a great tool in order to develop our flight controller and to test some safety algorithms. We have worked a lot in order to make this boat being able to fly over these big waves. The boat will take off at 28 knots. Once it has taken off, it's cruising at up to 45 knots. Thanks to this simulator, we could test the boat and the flight controller in big waves, up to 3.5 meter waves. It was a critical test in order to prove that the boat can fly in tough conditions. The simulator is really easy to use. We have a steering wheel here just for to steer the boat, basically, and a throttle here to accelerate and decelerate and control the speed of the boat. When I accelerate, the boat takes some speed and it will take off at 28 knots. Here it takes off. Once the boat is flying, to turn, it inclines like an airplane. To turn a little bit more, the flight controller is able to use a little bit more the rudders in order to turn more with a more narrow angle. With this simulator, we've been able to test different conditions. So a sea with little waves like this one, but we could also test in tough seas like this one, which simulates waves up to 3.5 meters. So you see here that the boat manages very well the waves, because that was the most critical condition on which we've been working. It's not straightforward to know how to control the flaps in order to maintain the flight as smooth and accurate as possible. Our flight controller is able to select which flap it has to use in order to maintain the flight. With this flying ferry, we've been looking for a slow dynamic which feels safe, because we don't really need to have quick turns and high dynamics. On this other boat, we have a small boat that's made for a few people. So here the goal is more to have a fun flying boat, and we have more reactivity, more dynamics in the turns. So the tuning between the two controllers is a bit different. On a ferry boat, we emphasize on safety, and on a small boat like this one, we emphasize more on the speed of the controls.